In this problem, a same-base supported beam 2 inches wide by 4 inches high and 12 feet long is subjected to a concentrated load of 2,000 pounds at a point 3 feet from one of its supports. So let's say it's right here. We're tasked to determine the maximum fiber stress and the stress in the fiber located 0.5 inch from the top of the beam. And to solve this problem, let's first solve for the reactions at the support. Let's call this RA and this one is RB. We have the summation of moment at point A equal to 0. Considering counterclockwise positive to solve for RB, we have a 2,000 pounds force times the distance, moment arm distance of 3 feet, and it's negative because it would induce a clockwise moment, plus the reaction RB multiplied by its moment arm distance of 12 feet, and it's positive because it would induce a counterclockwise moment, all equal to 0. Now we can solve for RB. We have negative 2000 times 3 plus RB times 12 equal to 0. Shift solving, we get RB equal to 500 pounds. And to solve for RA, we just take summation of force vertical equal to 0, considering upward force is to be positive. We have 500 pound force at RB plus RA minus the downward force of 2,000 pounds equal to 0. Solving, we get RA equal to 2,000 pounds minus 500 pounds equal to 1,500 pounds. Now we have direction at A and B to solve for the maximum moment, which tend to occur where the applied load is placed at the midspan. We can cut this segment and expose the moment and shear at this point. Let's call this shear V and moment M max. And the direction here, RB, is 500 pounds. And to solve for the maximum moment, this is a distance of 9 feet. We take summation moment at this point here. Let's call this point O equal to 0. Counterclockwise to be positive, we have negative M max plus 500 pounds times 9 feet equal to 0. We get M max equal to 4,500 pound foot. And that is our maximum moment. Now we can solve for the maximum fiber stress by using the formula for bending stress equal to MC over I. Weber moment is equal to 4,500 pound foot, and then the distance going from the outermost fiber to the neutral axis, this is 2 inches. And to make our dimensions consistent, let's convert this unit foot into inches by multiplying a conversion factor of 12 inches per 1 foot divided by the moment of inertia, that is equal to base times height cubed divided by 12. We have the base equal to 2 inches times the height of 4 inches cubed divided by 12. We get our bending stress, that is equal to 4,500 times 2 times 12 inch per feet, and divided by 2 times 4 cubed over 12. We get our bending stress equal to 10,125 pound per square inch, or psi. We can convert this into KSI by multiplying a conversion factor of 1 KSI, or kilopounds per square inch, per 1,000 pound per square inch. PSI will cancel. We get our final answer for the first problem. That's equal to 10.125 KSI. And for the second problem, we are tasked to determine the stress in the fiber located 0.5 inches from the top of the beam. You should have the word at midspan, which I forgot to place. Sorry about that. Now to solve for the moment at midspan, which we needed to solve for the stress, We cut at this segment here, at the middle. We expose the moment and shear. We call this M at the midspan and a shear V. We have a reaction at B that is equal to 500 pounds and a distance of 6 feet. Let us solve for the moment. This is just equal to 500 pounds times the moment and distance of 6 feet, which is equal to 3,000 pound-foot. Now that we have the moment at midspan, what we need here is the distance from the neutral axis to the point of interest. That is 0.5 meters, inches from the top of the beam. So if this distance here is 0.5 inches, the distance from this segment to the neutral axis is equal to 2 minus 0.5 equal to 1.5 inches. Now we can use our formula for stress or bending stress of the beam, that is F sub B equal to MC over I. We have our moment that is equal to 3,000 pound-foot multiplied by conversion factor of 12 inches per 1 foot multiplied by the variable c, that is 1.5 inches, divided by the moment of inertia given by the formula bh cubed over 12. We have our base equal to 2 inches times the height of 4 inches raised to the third power divided by 12, and we get our final answer. So we have the moment of 3,000 times the conversion factor, that is 12, multiplied by 1.5 over 2 times 4 raised to the third power divided by 12. We get our stress equal to 5,062.5 pound per square inch. Or to convert this into KSI, we multiply this by a conversion factor of 1 KSI per 1000 PSI. This is equal to 5.0625 PSI. And that is the final answer for the second problem, which is approximately equal to 5 KSI.